The wreckage still smoldered in the winter mud of occupied France, December 1943. Hauptmann Klaus Richter circled the twisted aluminum carcass of the American B-17, his boots crunching through ice-crusted grass. The bomber's tail section jutted skyward at an obscene angle, like a steel tombstone marking where 10 Americans had died moments before. But Richter wasn't looking at the bodies. His eyes locked onto something in the shattered nose section, something that made his throat tighten. A device, intact, gleaming. The thing German intelligence had been desperately hunting for 2 years. The Norden Bombsight. And what he was about to discover would make him understand, with crystalline clarity, why the Third Reich was already beaten. By late 1943, the air war over Europe had become a grinding war of attrition. Every day, waves of American B-17 flying fortresses crossed the Channel, their bomb bays loaded with high explosives destined for German industrial targets. And every day, those bombs found their marks with terrifying accuracy. German commanders couldn't understand it. Their own bombers, the Heinkels, the Dorniers, even the vaunted Junkers Ju-88s, couldn't hit targets with anywhere near the precision the Americans achieved. German bombardiers relied on mental calculations, visual estimation, and frankly, luck. Bombing from 20,000 feet meant dropping ordnance into a general area and hoping some of it hit something important. But the Americans? They were putting bombs through factory skylights, hitting specific buildings, destroying railroad junctions with surgical strikes that would have required dozens of German sorties to accomplish. The Luftwaffe High Command knew the Americans possessed secret technology, something called the Norden Bombsight. Intelligence reports described it in almost mythical terms. A mechanical computer that could calculate wind speed, altitude, air pressure, ground speed, and drift, all while the aircraft bounced through flak and enemy fighters. American security around the device bordered on fanatical. Bombardiers took oaths swearing they'd destroy the site before allowing capture. Each unit was fitted with thermite grenades designed to melt the mechanism into slag. Guards accompanied the devices from storage to aircraft. The American government classified it above top secret, which made Klaus Richter's discovery on that frozen December morning nothing short of an intelligence coup. Hauptmann Klaus Richter wasn't your typical Nazi officer. Born in Munich in 1914, he'd grown up in the shadow of Germany's humiliation after World War I. But unlike many of his contemporaries who embraced ideological fervor, Richter had fallen in love with something else: engineering. Before the war, he'd studied mechanical engineering at the Technical University of Munich. He could disassemble a BMW aircraft engine blindfolded and reassemble it by morning. His professors called him obsessive. His fellow students called him brilliant. The Luftwaffe called him indispensable. When war broke out, the Luftwaffe didn't put Richter in a fighter cockpit. They made him a technical intelligence officer, someone who could examine captured enemy equipment and understand not just what it did, but how it worked. And more importantly, why German equipment couldn't match it. By 1943, Richter had examined dozens of downed Allied aircraft. He'd studied British radar sets, American superchargers, even the hydraulic systems in captured P-51 Mustangs. Each examination left him with the same gnawing realization: Germany was falling behind. Not because German engineers lacked talent, but because they lacked resources, time, and increasingly, the raw materials needed to match Allied innovation. He'd seen the writing on the wall for months, but he'd never spoken it aloud. Not until today. Richter approached the bomber's shattered nose with 2 assistants and a photographer. The smell hit him first. Aviation fuel mixed with burned rubber and something sweet and sickening he tried not to identify. The entire forward section had crumpled on impact, but miraculously, the bombardier's station remained partially intact. And there it was. The Norden Mark 15 bombsight sat in its mount, scratched and dented but fundamentally whole. No thermite damage, no bullet holes. The bombardier must have died on impact, too quickly to trigger the destruct mechanism. "Photograph everything," Richter ordered quietly. "Angles, mounting points, connections, everything." As his team worked, Richter knelt in the wreckage and really looked at the device. It was smaller than he'd expected, about the size of a large typewriter, but infinitely more complex. Gears, gyroscopes, mirrors, precision bearings all integrated into a compact, ruggedized housing. He'd seen German bomb sites. Hell, he'd helped develop the Luftwaffe 7, Germany's most advanced bombing computer. It was a good site, reliable, simple enough for bombardiers to use under stress. But this was something else entirely. Richter's engineering mind cataloged the components as his fingers traced the mechanism. Automatic gyroscopic stabilization, multiple gear trains for simultaneous calculations, optical systems for target tracking. The precision manufacturing alone represented thousands of man-hours of machining, to tolerances most German factories couldn't achieve anymore. "Sir, should we remove it for transport?" one assistant asked. Richter nodded slowly, still staring at the device. "Carefully, very carefully, and get me a secure line to Berlin. RLM will want to know about this immediately." The Reichsluftfahrtministerium, Reich Aviation Ministry, had been hunting for an intact Norden for 2 years. Richter had just handed them exactly what they wanted. But as he supervised the delicate extraction, a cold certainty settled in his chest. This wasn't going to save Germany. It was going to prove, definitively, why Germany had already lost. 3 days later, in a Berlin laboratory converted from a bombed-out machine shop, Richter stood before a semicircle of Luftwaffe brass and RLM officials. The Norden Bombsight sat on a workbench under harsh fluorescent lights, its secrets about to be revealed. General Major Hoffman, a career officer with Iron Crosses from both wars, leaned forward. "So, Richter, show us this miracle weapon that's been destroying our cities." Richter took a breath. This was the moment. He could present the technical specs as requested, satisfy the brass, and send everyone home believing Germany could copy this technology and turn the tide. Or he could tell them the truth. He chose truth. "Gentlemen," Richter began, his voice steady despite his hammering heart, "the Norden Bombsight is indeed remarkable, but not for the reasons you think." He activated the device's power system, recovered batteries jury-rigged to German electrical standards. The gyroscopes hummed to life, their precision spin creating an almost hypnotic whir. "Observe the gyroscopic stabilization platform." Richter tilted the entire bench. The sight's internal platform remained perfectly level, compensating automatically for the movement. This maintains bombing accuracy even in turbulent conditions. The bombardier doesn't need to manually correct for aircraft motion. Several officers nodded appreciatively. Impressive, but not shocking. "Now, watch the computing mechanism." Richter began feeding in dummy data: airspeed, altitude, wind drift. Gears meshed and whirred. Mirrors shifted. The entire device performed calculations in seconds that would take a human several minutes with pencil and paper. "It's computing the bomb's ballistic trajectory in real time," Richter explained, accounting for dozens of variables simultaneously. Once the bombardier synchronizes the crosshairs with the target, the sight itself determines the precise release point. It's essentially automated bombing. Hoffman smiled. "Excellent. When can we begin production?" Richter's jaw tightened. Here it was. "We can't, sir." Silence crashed through the room like a physical force. "Explain yourself, Hauptmann." Richter gestured to the device. Look at the precision manufacturing. These bearings, he pointed, are machined to tolerances of 1/10,000th of an inch. The optical systems use specialized glass that requires rare earth elements we can no longer import. The gyroscopes demand ball bearings made from steel alloys we're currently allocating to tank production. He picked up a small gear assembly. This single component would require 20 hours on our best precision milling machines. The complete device needs hundreds of such components. And that's before we discuss the electrical systems, the stabilization platform, or the computing mechanisms. So it will take time to tool up production. Another officer began. No. Richter's voice cut through the objection. You don't understand. America isn't just building these as prototypes. Intelligence reports indicate they've produced over 50,000 units. 50,000? They're in every B-17, every B-24. They're not experimental technology. They're standard equipment. He let that sink in. To match this capability, we would need to completely retool our precision manufacturing industry. We'd need metals we can't access, machine tools we no longer possess, training programs for technicians we've already sent to the Eastern Front. And we'd need to do all this while American and British bombers turn our factories into rubble. Richter moved to a chalkboard and began writing figures. A single Norden bombsight represents approximately 2,000 man-hours of precision engineering labor. Multiplied by 50,000 units, that's 100 million man-hours devoted to one weapon system. For comparison, that's more total manufacturing time than we've invested in our entire fighter aircraft program this year. The room had gone deathly quiet. But here's what truly matters, Richter continued, his voice softer now. This device tells us something more important than its technical specifications. It tells us about American industrial capacity. He tapped the Norden sight. America can afford to build 50,000 of these complex, resource-intensive devices and still outproduce us in aircraft, tanks, ships, and everything else. They can throw away the engineering resources we can't even muster. Richter turned to face the assembled officers directly. Gentlemen, I'm an engineer, not a strategist. But I can read production figures. America is building 2 B-17 bombers every hour of every day. Each one carries a Norden sight. Each one carries 10 men we must shoot down to stop. They're building them faster than we can destroy them. Germany is building perhaps 3 fighters per day to intercept them. We're running out of pilots. We're running out of fuel. And now, having examined their technology, I can confirm we're also running out of time. The meeting ended badly. General Major Hoffman ordered Richter confined to quarters pending review for defeatism. 2 other officers demanded his immediate arrest. The Norden bombsight was crated and sent to another facility for further analysis, which Richter knew meant it would sit in a warehouse until war's end. But the damage, or perhaps the truth, had been done. Within days, copies of Richter's technical assessment circulated through the RLM. Engineers who examined the Norden independently confirmed his conclusions. The device represented not just advanced technology, but industrial capacity Germany simply could not match. Some officials tried to salvage the situation. Perhaps they could simplify the design, build a German version with looser tolerances, use the principles without the precision. But Richter's point stood. America wasn't winning because of superior German engineering skill. They were winning because they could build 50,000 of anything they wanted. Tanks, bombers, bomb sights, radar sets. They had the resources, the factories, the intact industrial infrastructure, and the workforce to simply outproduce the Third Reich into submission. The Norden bombsight became a kind of totem within German technical intelligence circles, a physical manifestation of industrial defeat. Not because it was so advanced. German engineers probably could have designed something similar given time and resources. but because America could build it at scale while Germany couldn't. Richter himself was quietly reassigned to a technical school in Bavaria, effectively sidelined from critical intelligence work. The official reason was reassignment based on skill requirements. The unofficial reason was that nobody wanted to hear his pessimistic assessments anymore. But the officers who'd heard his briefing couldn't unhear it. The engineers who'd examined the Norden couldn't unsee it. And slowly, reluctantly, the truth spread. Germany was fighting an enemy who could afford to put computational bombing computers in every aircraft, while Germany struggled to put engines in its fighters. The Norden Bombsight story reveals a fundamental truth about World War II that often gets overshadowed by tales of battlefield heroics. Wars of industrial scale are won in factories, not on front lines. Germany entered the war with some of the world's finest engineers, experienced soldiers, and initial advantages in doctrine and equipment. But they were fighting a war of attrition against enemies who could replace losses faster than Germany could inflict them. The Norden Bombsight wasn't special because it was technologically impossible for Germany to create. It was special because America could build 50,000 of them. They could equip every strategic bomber with a device that cost as much as a fighter aircraft and required specialized manufacturing techniques that Germany was allocating to other weapons systems. This same pattern repeated across every aspect of the war. American shipyards produced Liberty ships faster than U-boats could sink them. Soviet factories churned out T-34 tanks faster than German panzers could destroy them. British factories built Spitfires while German factories were getting bombed flat. Klaus Richter understood this the moment he examined that bomb site in the wreckage of a B-17. He saw not just a piece of technology, but a window into American industrial might. And he had the courage, or perhaps the foolishness, to say aloud what many German officers were thinking but couldn't articulate. Germany had already lost. Not in December 1943. Not even when America entered the war in 1941. Germany lost the moment they chose to fight enemies who could outproduce them by orders of magnitude. The Norden Bombsight didn't win World War II, but it perfectly symbolized why America would win. Because they could afford to build 50,000 computer-guided bomb sites while Germany was rationing ball bearings. Richter survived the war. He was captured by American forces in April 1945 during the final collapse of German resistance. In post-war interviews, he noted the irony. He'd tried to warn his superiors about American industrial capacity, and they'd silenced him for defeatism. "I wasn't being defeatist," he reportedly said. "I was being an engineer. I could read production numbers. The mathematics were very simple, actually. America was building too much, too fast. We couldn't match it. The Norden Bombsight just made it obvious." After the war, the Norden Bombsight's legendary reputation proved somewhat exaggerated. Later analysis showed it wasn't quite as accurate as wartime propaganda claimed. Weather, operator error, and combat conditions reduced its effectiveness. Many raids using Norden sites still resulted in scattered bomb patterns. But that almost makes the story more powerful. Even the imperfect Norden Bombsight, even with its limitations and operational challenges, represented an industrial and technological commitment that Germany couldn't match. America could afford to build 50,000 units of imperfect technology. Germany couldn't afford to build 5,000 units of anything. The lesson isn't about technology. It's about capacity. It's about industrial depth. It's about the cold mathematics of production that no amount of tactical brilliance or soldier courage can overcome. When Klaus Richter examined that Norden bombsight in December 1943, he wasn't just examining a bombsight. He was reading Germany's defeat in precision machined steel and carefully calibrated optics. And he understood.